was too.
Yeah.
So
What did I do?
Not anymore.
That's fine.
They probably still are.
How many are we doing?
Yeah, I got the
They
same.
probably won't fall much, honestly.
What's your good range?
They have the most.
How many are we doing?
What?
How many are we doing?
We're gonna do the first 5, and then we're gonna do the, I think 2 on the practice test. Or the semester
Wait, I
test.
have a question. Really good.
This is the chapter test. We have to do.
Yeah, but why are we? Oh, we're gonna do 2 more on this semester? What do you mean?
Yeah, because we're just doing a couple each day.
Yeah, but if they get
next.
up, coming back against them would be
Sure,
so
you're talking about
tough.
Sunday.
Why don't we just
You said why don't we just finish the entire? Yeah, can we do
No,
that?
we'll just do this.
They just played Iowa City West.
All right.
Wait, oh, it's because you're gonna make us do one by yourself.
No, it's because you're making us do 5 today, 5
Iowa City West.
I don't know.
But Ward, I can tell you a secret.
Ew.
Grandview played Iowa City
Gives me a
West.
lot of stress only
4A
these
versus
two.
1A.
Like this week.
West won by 10.
I don't care.
All right. Hey, let's walk through this real quick. Okay. I'm gonna walk through both of these pretty quick. You're gonna be finding the derivative, normal derivative. Now, why I pick these 2? They're inverse functions. They are inverses. Natural log is the inverse of e. Arc sine is the inverse of sine, obviously. But a lot of people forget like what arc sine is. We talked about it in class. That was one of the things we did prove in class. So natural log. When you take the derivative of natural log, because this is actually a chain rule, the derivative of natural log is 1 over whatever was behind the natural log. So it's whatever was behind, e to the x plus 1, right?
Since that's a chain rule.
And it's a chain rule, we have to multiply this. So again, that's how you take the derivative of natural log. It's 1 over whatever the natural log was. And then you take it times the derivative of the inside of what was inside the natural log. So what's the derivative of e to the x?
E to the X.
E to the x, and then the derivative of x is 1, so I can get rid of that. And what's the derivative of 1?
Shire.
Nothing, so that one go away. This is the final answer. This is the first derivative of that problem. I will not require that you simplify it. That's what I want to
I'm gonna
see.
start my apple.
Does everyone understand that?
Yes.
You're showing me that you know the first derivative of an inverse function and what the answer is. Now, what you have to make sure of, if you have to find the derivative of something like this, where I'm finding that first derivative of an inverse, we talked about this in class. I want you to go at some point today, go look it up, but this is what we talked about. It was finding that derivative of this thing, right? That's the first derivative, but it's the inverse function. We talked about that it was 1 over the function actually plugged in. It was this. And I believe it was the -1 on the inside. In fact, I'm going to write that down. Okay. This is the inverse stuff that we talked about. It was when we were taking the inverses of functions themselves. Let's see what section that was. That was, okay, it's 1 over, I have that marked wrong. It's 1 over the derivative of the function with the inverse plugged into it.
Is this for arc sine?
No, this works on anything that you're taking an inverse function of, right?
Is that what we did
This
number
is
1?
what we use to find arc sine.
Wait, why are we taking an inverse?
That's where this section is from. It was from the inverse section.
I don't get it.
So this is anytime you're doing an inverse of an, or taking a derivative of an inverse, you're taking the derivative on the bottom, you put 1 over the bottom, and then the inverse is plugged
There's no
into
bottom on
it.
that
That's the
though.
idea.
Mr. Ward, are you saying it's going to be an inverse on the test?
Yeah, because that's what those two are.
That's not an inverse.
Those are inverse. Natural log is the inverse of e.
What?
What?
See, this is
So
how
it's gonna
far
be a question
we
where I
are.
can tell us that.
No, I think you're coming on right now.
All right, now, arc sine. Arc sine, we did the derivative in class. We did this when we did tangent and arc tangent. We did it with cosine and inverse cosine. The inverse, or I should say, the derivative of this is 1 over the square root, 1 minus, and the item that's on the inside squared.
One apple. Squared.
So in our case, it's x squared, and we're going to square it.
What's the one?
It was negative out front. That was the one we were talking about.
And
Like,
then tangent.
tangent was the goofy one where it was,
So tangent's not gonna be on the test.
no, we did these. I'm gonna probably just pick normal if we did it.
Will you just pick arc sine?
Yeah, I just picked one because we did it in class.
Is it going to be cosine on the
Dad,
test?
can you please?
It could be cosine, it could be just some other random inverse function that I picked. where you just find the derivative using that little rule that we talked about, where you take 1 over the derivative with the inverse plugged into
You
it.
should do like an example of what you're gonna put on the test.
I don't know what we
Well,
have.
you're gonna.
An example of
You mean, other than the 2 that I put?
Ward.
No.
Open up your book.
Is that just the
Ward.
answer right there then, or?
Ward, can you
Uh,
explain
Wait, don't
that to
give
me
me
again?
this attitude right now.
So, now, we're not done yet. Now, this is 1 over the square root of 1 minus the item squared, whatever is behind it, times, and it's a chain rule, what was the derivative of the inside? 2.
X.
2x.
How do you get this?
There's your answer.
And if it was cosine, we just.
Ward, can you explain how
Yeah,
you
makes sense. I think
The
that makes sense.
Ward, can you explain how you got what you got in bottom crashing?
This is the derivative of arc sine. How we did this a long time ago. Yeah, there was the tangent, cosine. We did this whole process where we talked about how you actually figure that out is where it's when you actually take tangent and, or I should say cosine or sine. We can do sine.
Yeah, mine has
And
the-
you're doing the
based on my
inverse
first
sine
exercise.
on the inside, right? And we did derivatives where we talked about the function, the derivative of the function with the inverse plugged into it. And we talked about that these things cancel each other out and you're left with x, right? But the idea was like where that came from, like that huge square, is because it's the unit circle and or it's the triangle where you have 1 right here and you're trying to
Why is there
solve
shape?
x for like sine and cosine. That's where it actually came from. We did this whole process and we used, I think the way I cheated in class was I talked about the Pythagorean identities, and we talked about those. Where we did, I think it was like 1, or it was like 1 minus cosine squared is equal to sine squared, that's what we talked about.
How would we just put this problem on the test?
It was, all I'm doing is I'm gonna probably pick a normal one. I just put these on the test because they were just ones that I saw in the book that we talked
So the test
about.
itself will probably have.
It'll have the homework process we
counted
did.
wrong.
So
Nobody's
won't
getting
you-
this
Everybody
assigned.
No, it'll be something where you just take an inverse of an and you take
And
the
then nobody will have it.
So it'll just be like X squared plus 2.
I think it'd be like easier if you just showed us how to do it, like didn't explain it, because now
I have to
you're,
put
that
my
makes you.
numbers.
R sine, R tan.
They just said it, that way,
He
you know how to
it'll
do
just
it.
be, he pretty much just told me that, it's,
Yeah, where
he's
do you
one
get
minute.
this from?
He'll do like regular.
Like,
So-
What's a regular one?
I don't either.
I don't think you need, I don't think you need inverse. I think
We're just not supposed to explain something to you. Oh my gosh, I'm moving on.
Did it just say that teachers do not supposed to
Alright.
Call me a moron.
No, I said that was a dumb question.
In the lunch.
Alright. So,
Put that.
Okay.
He said, I was asked not to put something, that's the stupidest question I've ever heard. He's like, we're moving on.
number 3 and 4. Okay, implicit differentiation. This is where you have multiple variables, and when you take the derivative of things with respect to x, you have to put the letter behind it. I put a sign in there because we have taken derivative of normal sine. This is not arc sine. Derivative of sine is cosine. We talked about that a long time ago. All right,
We're
so
restricting X right now.
yeah, it's with respect to x. So when you do this, here's how you do it. We're taking the derivative.
Who? You. I was being stupid.
Whoa, why is that outside?
I'm showing you what I'm doing right now.
Respect to X.
You have to respect X.
Just write respect to X on it and just write.
What if we're respecting Y?
What if we want to disrespect X?
Wrong.
So all you did was put in
And X going to
d over dx.
You said yeah in my class then. You're half to respect that, otherwise you're
That's
out.
all you did is just put the d over
X,
dx.
X going to
He's gonna zip
I'm waiting
off.
for people to stop talking because I'm getting angry. So,
You're gonna hear don't know.
all right. So, taking the derivative. It's a chain rule on the inside, and this is a product rule. That's a product rule without a chain rule. This is just a derivative of a number. This problem is pretty lengthy, just this small portion of it, because we have 2 product rules. And we have that number on the other side. The derivative of the number is 0, so that other side's kind of easy. But the derivative of this part, because since it's a plus and, or a minus sign in the middle, you can take the derivatives of each side separately. So what we're doing here is I'm going to be doing this. I'll be taking the derivative with respect to x of the first part, which is a product rule. And then I'll be taking the derivative of this second part.
You're already out of room for the problem.
Yeah, no, I'm going to be writing it down over here.
Yeah, you
So, all right. So here's the idea. I'm taking the derivative of each part and I can separate them. The only part we have to remember is that this minus sign will have to be eventually distributed through this back part, which is kind of the more challenging part of the. And what we're going to try to solve for is dy dx. All right, so
Can we just write equal to right
I
here?
want to open up a sticky
Because I know the
note.
derivative of 6. By first.
0.
Are you guys burning my esophagus?
I don't think that's correct.
What?
My esophagus
That was
is
why
burning.
when you take derivative.
With the acid
This one's
from
just
the
the
fruit?
original.
I thought about that too.
You go to the
Are you okay with what? Yeah.
No.
Thank you.
You're welcome.
Wish we could just cover that up. That's
Are you just trying pixels?
okay. All right.
Just
Okay.
cross it out and go under it.
Now, taking the derivative of this thing, the product rule. I'm going to go through this pretty quick. Derivative of the first times the second plus the derivative of the second times the first. All right. So I already heard it. Ignore this stupid thing. All right. Derivative of the first is 2x times the second plus the derivative of the second is I don't know what y is, so I have to put the dy dx after it, times the
Wait, where's
first.
3 1 squared?
It's y to the third power.
Yeah.
Wait, what's that dy dx?
3y squared because you drop the power out
Why
front.
do you
Subtract
multiply the
dy dx because I don't actually
Because
know
he doesn't-
what y is.
Oh,
It's
you know
not,
what
it's not an
x
x. Yeah, we do know x because
So you
we're
gotta
putting
do
everything in
y
terms of
squared
x's.
and the dy
So,
dx?
So we take this, take the derivative. Now, behind, back here, now I'm going to the second part. This is technically going to be in brackets. And there's a 0 on that side because it's the derivative of 6. This part, taking the derivative of the first times the second plus the derivative of the second. This is the derivative of the second is 1 dy dx times the first. So anytime I take a derivative of y, I always have to put a dy dx there. It's supposed to be a 1 dy
Then why'd you
dx.
do
Because we don't know what y is, so we always have to put it in respect of x's. So it's, I don't know what.
I was looking at like the top versus the bottom, you know?
Okay, now,
Okay.
solve, I'm going to distribute the negative sign. So here's what we have. We have 2x, y to the third. I get, right here, this is 3x squared, y squared, dy dx. And now I'm going to distribute the negative sign to the back. So, moving the negative sign to the back, I have a negative y. I have a negative x dy dx. And I have a 0 on that side.
Is that
Is that the
2x
answer?
3 at the beginning?
2x, y to the third.
No, the beginning. Yeah, that. You're right. I didn't spit a lot there.
Wait,
Wait, is
Alright.
that the final answer?
No, we have to solve for dy dx. You have to take everything over that doesn't have a dy dx to the other side because we have to solve for dy dx. That's the whole point of this.
So are you not putting the x in there?
What?
Never mind, it's the same thing if I
So we
put
add
a 1
y
here,
and
you
then we
just did it
subtract
and confused me.
2x y cubed.
How come on the top you didn't write dy dx, you just wrote d over dx?
Because I'm taking the derivative with everything with respect to x. And this is just
Oh,
showing
and
what
now
I'm
you're
doing.
respecting y?
Now, no. Well,
He's disrespecting
I'm
y.
still showing respect to x. It's just I don't know what y is, so I just put a y behind it, showing that I don't know what y was, but I'm taking the derivative of it if there's x in it.
You need to show
Alright.
y some stuff.
So,
What?
it's notation for the derivative.
Ow.
All right,
Look
moving
it.
the y over it becomes a positive. Moving this item over became a negative.
But you don't respect it.
All right, and so this is what I have so far. That's moving everything over the side with the 0 went away.
Are we gonna divide by?
And then, yeah, we're gonna factor out the dy dx part. dy
Well, then we'll divide
dx.
by that whole mess, right?
And yeah, whatever this item was, whatever that item was that was in front of the that was in front of these dy dx's, that's in the back here.
There's no way I'm gonna get that's on test.
And I'm gonna divide by that whole
Whoever
mess.
just said that same.
So, your final answer is this. So dy dx, I'm going to divide that whole parenthesis to the bottom, and
That
here's
ma-
what I get.
That mad mess.
I'm literally gonna fail this test.
Can we call it a mad mess?
3x squared,
It's okay,
y
just-
squared minus x. There you go. That's solving for dy dx. That was the second section we covered
That was so
in the beginning of the
much
Is that
chapter.
the final answer?
Final answer.
Good deal.
I don't mind solving.
You're just going so fast and I didn't.
I got,
Now
I'm
the
on
sin
a time
gets
crunch.
where I'm
Yeah,
like,
we
Yes,
half
I
this
get that, but I
My
don't
sin is like-
understand.
So, you can come in anytime you want. I'm
What the
always
hell is
available.
sine? Why is
Actually,
Except on
I
the house.
would.
On the house.
Should I go to your house and that?
Nope, that's awful. Okay, alright, so, are we good with the first one?
Hold up, let me just
Yep.
try one. I'm good, thank you.
Alright, I feel like I
Okay, moving on.
That's okay. Just write that thing right there.
What will my grade
There's
be if I
something
fail
I
this
was
test?
I don't know.
Alright,
I
moving
had a
on.
really high No, I'm counting on like a 10. Senior, I was real. For my.
Okay, alright, number
If
4.
I spell that right.
Let's make this.
If Jay doesn't respect that.
Alright,
I'm gonna read.
same thing, derivative of x with respect to y. So, here's the idea, taking the derivative of this side, this is gonna be cosine of the inside.
Wait, I have a question. How do you know whether it's with respect to x or with respect to y?
Anytime you do the implicits, it's always with respect to x.
What?
But when would it be respect to y?
If there's only y's in the problem, you're picking out the letters.
Why'd you
I
do
But
that?
you just said respect to y now, and there's x.
I'm moving on from these terms.
No, mine is
No,
actually about the problem.
I'm actually confused.
It's always x unless the variables are different, then they tell you what respect that you're going with.
But you just said y.
X, Y.
It's with respect to x.
To the line.
Oh, but you just, like, I was confused. 'cause you said y.
Alright, question?
Cosine is the derivative of sine.
Derivative of sine is cosine, then I have to take the times the derivative of the inside, which is this.
Over.
Plus 1 dy dx times x. So that's the derivative.
The cosine.
So this is the derivative of sine is cosine. And then I take it times the derivative of the inside this thing. This is a product rule. There it is. And that equals the derivative of the other side. Well, the other side is just a 2. So that's the derivative of 2x and the derivative of 5.
Is that the answer?
Now we have to solve for dy dx. So I'm going to distribute the cosine through. If you don't want to, you can always divide it over. I think it's easier if you just distribute. So if I distribute, here's what I get. I get 1y cosine xy. I'm going to distribute the cosine back here, so I get 1x cosine xy, and the dy dx is after it. And the 2's on the other side.
Where'd the 1y come from?
That's taking the derivative. This whole parenthesis is the derivative of what's on the inside. So it's a chain rule. It's derivative of the outside
The
times.
bottom. One underneath, 1y in front of that.
Distribute this through.
Okay.
Because it is a parenthesis, you have to multiply it through the parenthesis. Solving for dy dx. We're going to move that everything over. So here's what I have so far. I have a 1x cosine xy dy dx. I'm going to move that first item over and it becomes negative.
I was like, it doesn't expire.
And the last step is divide everything that's in front of the dy dx part. So your final answer for dy dx, if I divide it by everything out front, what do I get?
Dy dx equals 2 minus 1y cosine xy divided by 1x cosine xy.
Boom, done, move on.
Wait, so we don't need to reduce that or anything?
Nope, we don't reduce anything, we're just doing the first couple steps.
Are you gonna be bothered if we don't put ones out front? Because I
No,
notice
it's not
you
a
do
big
that quite often.
I'm putting it there so you can understand that I took the derivative of that letter and it's still supposed to be there. Because if I just threw a y, I wouldn't wonder where it came from.
I really should have brought glasses.
Alright. Number 5, the last one. We have to find critical points and inflection points at number 5. So we'll do that one here in a second. So far, it seems like the ones we need to really focus on right now is number 1 and 2 for sure. Finding those inverses. So if we have time tomorrow, we might go through another example of that.
On the test, you said you're gonna do normal ones, so that
Yeah, just normal ones where you use the inverse.
So it's just like a regular derivative thing, and you just have to flip the x and y. So that's what you're doing.
Yes,
I
that's
think
what
just
you do is
normal
first
properties.
derivative is
I just picked 2 that were inverse.
Second derivative is
So I just picked 2.
That's all.
But I didn't realize it was such a deal.
Oh.
Well, you have to like do the graphs, don't you?
Which one? On the test, we have a little bit more space, like
Well, obviously
Again, it'll just stretch out to more pages.
that's fine.
I'm
Because
trying to fit it on one.
I'm cramming this up.
Alright, let's move on to number 5.
There's a lot.
I'll probably stretch it out so the first 4 will be on the first page. And then I'll move 5 and 6 to the next, and that means that we'll probably move 9 and 10, or 8, 9, and 10 to the next page. So it'll be a 3-pager. Alright, let's go to number 5, critical points. We're only gonna do number 5 today. To find the critical points right now, you have to take the first derivative and see where those equal 0. Can somebody walk me through the first derivative here?
3x squared minus 18x plus 24.
And you can factor out 3.
Okay, good, factor out of 3.
Otherwise.
That's 8, not 12.
Oh, just 1 minute. Thank you. Yeah, you're right. 4 and 2, and it's negative.
negative, yeah.
Alright, and there's 2. Alright, and so the idea is that you're right, the critical points are going to be at 4, and the other critical point would be at positive 2. Now, if you couldn't factor that apart, let's say you didn't know how to factor it, quadratic formula is always your next go-to. You just plug, you could take that 3x squared minus 18x plus 24, plug it in the quadratic, and it will give you your other x's. That will be the critical points. I'm probably going to pick one that's factorable, just let you know.
Is that it?
So that's the first part. So these are the critical points. The second part, we have to do inflection points.
Oh, that.
6x.
Second
Second
derivative.
6x minus 18.
Okay, so second derivative now. These are for inflections. 6x minus 18. Okay. And we solve that thing for 0. So factor out of 6, it's x minus 3. And so the answer would be positive 3. So that'd be your inflection point. That's it. That's what you do.
It's a good deal.
Okay, now why we're doing these two? These two are important when we did the global and relative minimaxes, that type of thing. They call them global and local. That's the parts. So it looks like right now what we'll do is we're going to go on to the semester test today because I want to finish up maybe 2 on there. Maybe tomorrow we'll start with maybe an example of 1 and 2 again, because it seemed like that for sure was something that a lot of people did not understand today. That was a long time ago, so we'll probably review that first. I'll go through the inverse formula one more time so you know how to do it. So that'll be tomorrow, and then we'll get into
our
this.
semester test now?
Semester test is Thursday next week.
No, like our.
Oh yeah, we're moving on to the semester.
Not that much.
Okay, all right. We got about 10 minutes. All right.
No, I thought you
More than some.
This not something.
Mari, like my socks that I wear
I
today?
didn't even get the first question.
I'm on number 18 now.
All right. Okay. Now, yesterday on our practice semester test, we did problem number 1, we did problem number 2, and I believe we did number 3.
Yep.
Okay. All right. So 1 through 3. All right. So today we're going to start with number 4, and we're going to try to go to number 5 today. These are the big ones. That's why I kind of warned you. I'm only going to probably have time for 2. All right. So let's get number 4 ready to go here. We're going to try to graph this. Now remember, on this problem, you don't use this graph. Okay, this graph was for the top one. This for number 1. I'll probably try to move this where it's more near the top one. It wasn't gonna fit right, so I just moved it to the bottom.
Just make a mock sketch, right?
All right. Okay, let me turn it off.
How many
Camera's
points
working.
is chapter 4 gonna be out of?
Like the test.
It's nothing huge.
All
All right. Okay.
I have a question.
Like, this is an honest question, if I like did bad on that, but I have a good grade in this class, like it's not
Starts in the middle,
terrible.
so it's up.
Should be fine.
Alright,
Hold on.
alright.
That's what you want. You'll
Just
probably
show
want to
work.
retake it
Starts
before
like
the end of the
this. It
semester.
starts up here.
Do you do 40, 40, 20?
On top of that.
Semester doesn't
Okay.
end until we come back.
All right. All right, on this problem, this is a sign problem again. Hey, ignore the graph. I'm going to go through this pretty quick. You're going to have to kind of pay attention here. Okay, first, the period length. Okay, the period length, what we normally do on sine cosine, because it'll be a sine or cosine problem, the period length is normally 2 pi. So if you don't remember that, this is what it normally goes out to. Right, it goes out to 2 pi. We're not going to hit 2 pi on this one because there was a number in front of the x, correct? There was a number in front. Now, again, wait to draw this until later, because we're going to move this thing up
So
and
it's gonna
down.
be pi.
Okay, so if we divide by the number in front of x, you're absolutely right. My 4th marker, by normal standards, would be at pi. Don't draw that yet.
Don't you add pi now?
Okay, so this would be pi. Pi would be at the 4th marker. The reason why it's not at
We
pi
shifted left.
is we've shifted it. And you're right, we're going to the left. We'll talk about it here in a minute. But normally, if there's a number in front of x, this is where your period would be. That would be the 4th marker. You'd cut it in half, you cut it in half again. You guys remember those rules?
Yeah.
Multiply by 3, okay. It's important that we remember those basic rules because if you shift it right and left, there's just one extra rule we add to it. Why I did all that is because this was the most important thing I wanted you to think about. That it's pi over 4 for the first marker if there was a 2 out in front of the x. So this is actually the leap, this is the actual spacing between each marker is pi over 4. And you had to actually find that by doing a mock picture of it, what it should have been before I moved it right and left.
But isn't it always
Okay.
pi over 4?
No, because this will, yeah.
Oh.
But the idea is that we're going to be shifting it right and left, and it'll get really messy where this thing is going to be. Does that make sense? What the pi over 4 came into?
Yeah.
Okay, now, this thing, I'm going to go back and get rid of this graph. Alright, this graph is being shifted, and you're absolutely right, we shifted it left. And how I know that is because what you do is you take this whole parenthesis that's behind sign, and you set it equal to 0, and then you just solve. I subtract the pi over, and I divide by 2, and this is where my start of my graph would be. It'd be here at negative pi over 2. It's that, this is my starter marker, it's not 0, 0 anymore. And why that's important is because now to get to those other markers, I have to use my spacing. Pi over 4, 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 and I have to keep going until I get my 5 markers. My 4 markers, I should say. Because this is where I'm starting. Now this line, there's not an actual asymptote, I'm just putting, this is where I'm starting. This is where I'm starting, and I'll draw the sine graph from there. But it has to go 4 markers this direction, so in fact I don't even need this marker. I'm going to probably hit this one. This will be my final 4th marker right here. Because-
Can you erase the end of that line?
What?
You didn't erase it. Thank you.
Okay, so this marker is negative pi over 4. How I know that? It's going over pi over 4. Going over pi over 4 again, I hit 0. Going over pi over 4 again is positive pi over 4. And then going over pi over 4 again is pi over 2. Because it's perfectly like spaced. And I'll try to make one that's usually something like that.
Thank you.
Okay. Now, to graph this, we have shifted my graph up 8. It's up 8. So this middle line is actually 8 up in the air. Okay, does that make sense where the middle line is? It's actually at 8. So I'm way above 0, 0. Okay, 0, 0 is like down here. Okay, so I'm shifted up 8. The actual amplitude is negative 4. So that means I'm going to be hitting markers 4 above and 4 below where my starting point was. Now, this is the sine graph, right? The sine graph normally goes up, down, and back up again. But since this is negative, because technically this plus 8 should have been back here. This is how they normally write it. They write it normally like that. The negative sign means I'm going down instead. So it's drawing the sine graph like upside down. So this is what the sine graph is actually looking like. It's going to hit the lowest point at the first marker now, come back to 0, go to the highest marker, and then come back to 0 again. That's my graph. That's my final answer. Sine graph usually goes up. It makes like an S shape for sine. But now I'm going kind of backwards.
It makes sense right now.
Right.
Now cosine, the only difference with
Wait,
cosine...
really fast. It makes sense right now.
It makes sense right now.
Right now?
Don't you see an S?
Oh yeah.
But like if it goes the other way, it's an opposite X. Is it not? Yeah.
I guess it would be.
Oh, that's so bad.
Okay.
It goes up first. That's wrong.
Now cosine normally looks like this. This is what cosine graph usually looks like. It looks like a U shape.
Amplitude.
So if we had
Or
to
an
shift it
N
right to
shape.
left, up and down, or an N, you flip it over.
Or a V.
So D.
C.
V.
No, it looks like a
It's a
C.
cursive V.
Oh, I see what you're saying. I think I said B now.
That's what I thought.
Sorry.
Yeah, it looks like this.
All right.
Cursive.
Okay, we're good.
Yep.
Moving on. Last one today. Now we might have to just continue this one tomorrow whenever the bell goes off.
We have 3
Which is
minutes.
fine. Yeah, that's fine. I thought that one was going to take me way longer. All right. Okay.
Yeah.
Moving on. Here we go. Okay, this one. This problem is from one. I think it's from our 3rd chapter test. This is one that a lot of people did not like on the 3rd chapter.
I didn't mind fourth chapter. You know what I do mind fourth chapter?
All right.
We have 3.
This one we have to figure out where the tails go, where the asymptotes are, where all the intersection points are, all that good stuff.
We don't pay you for it.
Inflections, whatever. All right, symmetry and behavior. All right, what can you tell me since these numbers are the same?
0 asymptote.
0 for the asymptotes, horizontal.
I can't believe I know that.
Which?
So that means the tails are going to flatten out at 0 because, hopefully everyone's paying attention. Since those numbers matched, we're flattening at 0. Okay?
If the top one's bigger than 1.
If the top one's bigger, you don't have it horizontal.
In
If the bottom one's bigger, you have it wherever that number is. Oh no, I have that backwards. Hold on.
Are you kidding me?
Ooh, hold on. Okay. Oh, I almost made a huge mistake.
Wipe this
Okay.
Put a 1.
Asymptote of 1. Because since they're the same, you divide
Oh
them.
god, I hate myself.
Oh,
See, this is what I'm talking about. I was like,
you said it, and I was like, oh yeah, that makes sense. All right. No, if the bottom is bigger, so if the bottom is bigger, that's when you have it horizontal at 0. Yes. Oh man, I almost got that wrong.
What's the top bigger?
Ooh. All right.
So if we get that one wrong, it's justified.
No. So I almost did it wrong. All right. So we're having a horizontal at 0. Or sorry, geez, I said it again. At 1. All right. Now the vertical asymptotes. Those are the next things I'll fill in. You have to solve for the bottom because you can't divide by 0. How do I factor the bottom apart?
X minus 2 plus 2.
Wait,
Plus 2 minus 2.
What do we do if the top's bigger?
The top's bigger. There's no horizontal. If the top is bigger, there's no horizontal. Okay, so what we have here at the bottom is going to be -2 and +2. That's where your asymptotes are going to be. So, and these are vertical ones now. So we have vertical asymptotes there and a vertical asymptote here.
And if the bottom's bigger, it's at 0?
Yes. If they're the same, you have to divide the numbers out. All right, so there's your vertical. So it looks like I'm going to have 3 pictures. We'll continue tomorrow. Stay, and we'll probably start tomorrow with a review of the chapter 4 stuff.